Hey everyone! Welcome, Junior Space Explorers, to today's interactive virtual science lab. I am just so excited to be your guide on this incredible journey. We're going to be traveling all the way from our glowing moon right out into the deep, sparkling stars. You know, if you've ever looked up at the night sky and wondered how the whole shebang actually works, you are in the exact right place. So, go ahead and grab your imaginary spacesuits because we have a lot of exploring to do. Okay, let's dive right into this. Here is our 6-part mission plan for the day. We've got the moon's secret light, rotation and orbit times, simulating moon phases, the lunar calendar, constellations as our compass, and we'll wrap it all up with a Space Explorer pop quiz. All right, let's blast off. Mission 1, the moon's secret light. Okay, I want you to close your eyes for just a second and imagine you're looking up at a totally clear, beautiful night sky. Right in the middle is this giant glowing moon. Now, open your eyes. Here's a question for you. Does the moon make its own light? Think about it for a second. Is it acting like a giant light bulb up there, or is it more like the sun? Keep your guess locked in your head because we're about to find out. To solve this mystery, we can actually just picture a really simple experiment. Imagine you're hanging out in a pitch-black room. One friend is holding a flashlight, and another friend is holding a mirror. When you shine that flashlight directly onto the mirror, wow, the mirror suddenly looks super bright. But wait, is the mirror making its own light? Well, no, it's just bouncing the light from the flashlight. And you know what? In space, the sun is our giant flashlight, and the moon is just a massive mirror. So, the crucial takeaway here is this absolutely vital science word, reflection. The moon literally does not emit its own light. It simply reflects the light from the sun. That bright, beautiful glow you see at night, that's actually just the moon catching the sun's rays and bouncing them right down to us on Earth. Pretty cool, right? Mission 2, rotation and orbit times. Now that we know why the moon glows, we really need to talk about how it moves while it's up there hanging in space. The moon actually does 2 totally different dances at the exact same time. First, it has a rotation on its axis. Actually, think of it like a basketball spinning on your finger. That's the moon just spinning around itself. Second, it has an orbit around the Earth. That means it's traveling in a giant anti-clockwise circle all the way around our entire planet. Now, what's really interesting here is this specific number, 27 1/3. It takes the moon exactly 27 1/3 days to complete one full spin on its axis. And guess how long it takes to orbit all the way around the Earth? Yep, exactly the same, 27 1/3 days. Because these 2 movements take the exact same amount of time, the moon is basically locked in a synchronized dance with Earth. And because of that, we always, and I mean always, see the exact same face of the moon looking down at us. Mission 3, simulating moon phases. So, wait a minute, if we always see the same face, why does the moon seem to change its shape every single week? Well, we can actually simulate this right at our desks using a moon phase cup experiment. If you take 2 plain paper cups, insert one into the other, and sketch the different moon shapes on the inside cup, then you cut a little viewing window on the outside cup and stick on some labels. When you slowly turn the inner cup, boom, you can watch the phases change step by step. This happens out in space because as the moon orbits the Earth, we just see different amounts of its sunlit half. All right, my junior explorers, I want you to grab a pencil and your science notebook right now. Let's sketch these shapes out together. Start with a totally blank circle for the new moon, then draw a tiny sliver for the crescent moon. Next, draw a neat half circle for the half moon, a slightly bulging shape for the gibbous moon, and finally, a big, bright, complete circle for the full moon. As you're drawing these, just remember, the moon itself isn't actually changing shape up there, it's just our view of its sunny side changing. Mission 4, the lunar calendar. Now, these changing shapes, they aren't just up there looking pretty, they actually serve an incredibly important purpose for people all around the world. The phases of the moon are, quite literally, a giant clock in the sky. The lunar calendar, which is also known as the Hijra calendar, uses these exact moon phases to track time, determine dates, and mark really important Islamic celebrations. For example, looking up and searching for the very first sliver of the new crescent moon is exactly how we know it's the start of a brand new month, like the 1st of Shawwal. Mission 5, constellations as our compass. For our next mission segment, we're going to look way past the moon, much deeper into the dark night sky, right to the stars themselves. Long before we had GPS maps on our smartphones, ancient sailors, travelers, and explorers used the stars as a giant natural compass. By looking at specific groups of stars that form patterns, which we call constellations, they could figure out exactly where they were and which way they needed to steer their ships in the pitch dark. There are 4 main constellations, or Baruj, that you definitely should know. The Big Dipper, or Bidik, looks kind of like a giant soup spoon, and it always points north. Then there's the Southern Cross, or Pari, which is the absolute smallest, shaped a bit like a kite, and it points perfectly south. Orion looks like a mighty hunter, and you can spot it right between the northern and southern hemispheres. And finally, Scorpion, or Scorpio, well, it looks just like a giant scorpion, and it helps us identify where other stars are located. Imagine being a sailor lost on the ocean, and finally spotting that kite-shaped Southern Cross to safely guide your ship south.
Mission 6, the Space Explorer Pop Quiz. All right, explorers, you have learned so much today, from the moon's giant mirror trick to using stars as a trusty compass. It is officially time to test your knowledge with a rapid-fire Space Explorer Pop Quiz. Here is your first question. Feel free to just shout it out at the screen if you know it. How long does it take for the moon to complete one full orbit around the Earth? Think back to our magic number. The answer is 27 1/3 days. Great job if you remembered that exact fraction. And don't forget, that's also the exact same amount of time it takes to spin once on its axis.
Okay, question number 2. Let's see how good your starry navigation is. Which constellation acts as a compass that always points south? Hint, it's the smallest one we talked about, and it looks a little bit like a kite. It's the Southern Cross, also known as Baruj Picari. Excellent work tracking that one down. And for our final review question of the day, we are going all the way back to our very first experiment. Does the moon emit its own light?
No way, it definitely doesn't. It reflects light from the sun. And this just brilliantly illustrates how our whole solar system works together, right? With the sun providing all the light and the moon acting as a giant beautiful mirror in our night sky.
You have all been absolutely fantastic junior space explorers today. But before we sign off from the Science Lab, I want to leave you with one final mystery to chew on. If the moon's exact 27 1/3 day rotation and orbit mean we always only ever see the exact same face, what do you think is hiding on the dark side of the moon? Keep wondering, keep exploring, and I'll see you on our next mission.